The beginning of exponents. We're going to start with quotients of exponents. Things that we need to remember is that multiplication, these are some of the laws that you need to know. Multiplying like bases, we're going to add their exponents. When we have a power of a power, we can distribute it to each of the items. So you can distribute exponents into the quantity. When we divide by like bases, we are going to subtract. This is not anything I'm ever going to teach. I'm not going to teach you that. When we have a power of a power, it's kind of like distributing, but we're going to multiply their like bases. And then when we have division, very much like this, it should actually be here, we can distribute into division also. We can distribute into multiplication, we can distribute into division. Those are the main rules, so let's go through them. We're going to start out very basic. There are a number of ways of doing this. The easiest way is to find the prime factorization of 18. We can do prime factorization rules. 18, which is 2 and 9. 2 is prime, so we can circle it. 9 is 3 and 3. We can divide it. I feel like I've done this video before. And we can break 9 into 3 and 3. So the prime factorization of 18 is 2 times 3 times 3. And 48 we can break into 2 and 24. 2 is prime. 24 can be broken into 2 and 12. 2 is prime. 12 can be broken into 2 and 6. 2 is prime. 6 can be broken into 2 and 3. And now we have the prime factorization of 48, which is 2 times 2 times 2 times 2 times 3. And we can cancel. 3 over 3 equals 1. 2 over 2 equals 1. And that leaves us with 3 in the numerator and 8 in the denominator. So this reduces to 3/8. And I'm going to look. I should have videos of this, so I'm going to just check my website real quick. And I hope you don't mind being patient with me. My Google account. And I'm going to look at my videos. And I'm going to look to see if I've taught 5-1 already. 5 times 5, no. Gosh, it really does feel familiar though. Pre-assessment, no. Big ideas, definitely not. These are algebra. All right, I guess I didn't. It feels really familiar though. All right, I guess I did not do this. That one looks, that's 6-2 though, algebra, detailed answers. Yeah, that's, I guess, where I did it. Sorry to delay. Sorry. Okay, at least it's nice to know that I'm not duplicating my work. So that's one way of doing it. The other way that you might want to do it is by finding a common factor. So I know that 2 goes into each of those. So 18 divided by 2 is 9. 48 divided by 2 is 24. And now 2 doesn't go into those, but 3 goes into both of those. So I'm going to divide both of those by 3. 9 divided by 3 is 3. 24 divided by 3 is 8. And notice we have the same. Now the last one is we can find the greatest common factor. So I could notice that each of those is divisible by 6. 18 divided by 6 is 3. 48 divided by 6 is 8. So I can choose the GCF, or I can just choose common factors each time. So 3 different ways to doing it. I'm okay with any way you want. I'm going to reduce this by 9. And 9 goes into 36 4 times. 9 goes into 63 7 times. So we get 4/7. I'm going to try to do the most efficient. 4 goes into each of those. That's 25 by 4. Divide by 4 is 6. So we get 25 over 6. 9 goes into each of those. So that's going to give me 6 and 10. Oh, so I did not pick the greatest common factor, which would have been 18. I don't see that 18 goes into 54. That would have been hard for me. But it does. It goes in 3 times. And sometimes we're going to see it. So here's the big idea. We're going to take our coefficients and deal with them in one manner, and then we're going to take our like variables and deal with them in a different manner. And that's what this section's all about. We have to remember that coefficients are going to be treated differently than like bases with their exponents. So 8 over 2 is going to produce 4, and t over t squared is going to be t to the 1 minus 2. When I have like bases, I'm going to subtract their exponents. And this gives me 4 times t to the negative 1. That is one answer. It doesn't say anything about having negative exponents. Now, if you want to not have negative exponents, you would write it in this manner. We would move, getting rid of the negative exponent, we would move it into the denominator, change its location. So I'm going to deal with the coefficients in one way, and then I'm going to deal with my like bases in a different way. So what goes into 16 and 24? 8. 8 goes into 16 twice. 8 goes into 24 3 times. And then I have x to the 4 minus 1. So that is 2/3 x to the third is one answer you can give. You could also put all the stuff in the numerator and write it like that. Either answer is good. You're going to tend to see this for high school. This is going to be a high school answer. We're going to deal with the coefficients, and then we're going to deal with the like bases. We want to reduce 18/9 over 2. We are dividing like bases, so we are going to subtract their exponents. We get 9/2 y to the negative 2. Now, rarely will you see it in that manner, but that's acceptable. You might see it like this. I don't know if you'll see that. Since there's a denominator, most people will move that negative exponent down with that denominator, and this is probably your high school answer. That's what you're going to tend to see. Coefficients. Now we have multiple like variables, so I'm going to separate each of those. So I have 3 things. I'm going to treat some of them the same and some of them different. Coefficients, I'm going to treat them like a fraction. Like bases dividing, I'm going to subtract their exponents. And I'm going to subtract their exponents. This gives me 1/3 a to the 1, b to the negative 1. So I'm going to keep the a up in the numerator, the 3 is in the denominator, and b to the negative 1 I'm going to write in the denominator. I'm not going to write a over 3b to the first or a to the first. I'm not going to write with a power of 1. Wrong. Don't write to the power of 1. I'm going to deal with the coefficients. I'm going to deal with the variables. I'm going to deal with the other like variables. That's going to give me 2. That's going to s to the 1 minus 1. That is t to the 2 minus 3. 2 times s to the 0, t to the negative 1. S to the 0 is equal to 1. To the negative 1. That's going to give me 2t to the negative 1 is one answer, or 2 over t. I don't mind either one. 15 over 18 is going to be treated differently than p to the third over p to the second, q to the second over q. So 15 and 8, 3 goes into that, 5/6. P to the 3 minus 2, q to the 2 minus 1. And we get 5pq over 6. So I'm doing all of those steps in once. We should be able to get proficient at it. At this stage, we have constants. Just because we have constants, don't treat them like a fraction. We cannot cancel the 8 over 8. We have to do exponents. We have to do exponents before we do division. So you cannot cancel the 8s. It does not become 1 to the 7 minus 5. No. No. That's 8 to the 7 minus 5. Remember, like bases, we subtract their exponents. That's 8 to the second, which equals 64. Let's take this. Let's make it a little bit smaller. Let's make it red. So understand that it doesn't become that. That is a big no-no, common mistake. This is 4 to the 2 minus 5. We have like bases. We have like bases here. We are dividing those like bases, so we are going to subtract those exponents. The division is subtraction. So that becomes 4 to the negative 3. Negative exponents go to the denominator when it's in the numerator. We're going to change it from negative to positive. We have to change its location. And think about this. We have 4 to the second, 4 to the fifth. We have 2 4s in the numerator. We have 5 4s in the denominator. These are going to cancel. It's going to cancel with 2 from the bottom. So if we take 2 of those 5 away, guess what we're left with? 3 of them. And where are they? They're in the denominator. They're in the denominator. Yeah, so that becomes 1 over 64. Whoa. 1 over 64. You want to do it in this fashion. We want to be doing this stuff. We want to be doing this stuff. 1 over 64. This is the technique that we want to use. Now, if we need to understand it, it's okay to look at it like this, but we want to be doing division. We are going to subtract only when they have like bases. They both have a base of x. So we are dividing. We are going to subtract their exponents. We get negative 1. We must get rid of. Actually, I guess both answers are correct. But in this case, I'm going to show you both. I guess both are okay. That can be simplified. You can't leave it as a negative. So both of those. So once we get variables, we can actually leave it in either fashion. We would never turn it into a negative exponent. So t to the fifth is the correct answer. Oh, yes. So remember, that's a coefficient. What's the coefficient here is 1. So that's different than our bases. So we're going to get 5a to the 3 minus 5. And that's 5a to the negative 2. Remember, this is 5 times a to the negative 2. So we're going to treat the coefficient differently. And we're just going to move the base of a. We're just going to move the a squared. Now, this could be an answer because it doesn't say anything about having negative exponents, but both of those could be the answer. That 8 is by itself. We're going to do y to the 6 minus 3. That takes place in the numerator. This is a really good problem. I don't remember this one. That takes place in the numerator. So we get y to the 3 over 8, and the 8 was in the denominator by itself. So it's unaffected by the like variables. We are going to distribute a power of a power. So we distribute it to each of the terms, each of the items. 2 to the 2. When you take a power of a power, you multiply. We get x to the 4th over 81. That is 4 to the 2nd over z to the 3 times 2, which is 16 z to the 6th. Really good problems. All right. Now we have, again, let's deal with our coefficients. Let's deal with our like variables and like bases. So coefficients we're going to deal with different. 9 goes into that, 3 and 2. Then we have x to the 3 minus 4, and we have y to the 5 minus 2. We're subtracting because we're dividing those like bases. So 3 to the 2nd times x to the negative 1, y to the 3rd. My 3 is in the numerator. My 2 is in the denominator. I'm going to get rid of that negative exponent. So I'm going to move it. And I'm going to keep the y to the 3rd in the numerator because it's positive. Now, you can have this as an answer. You can have 3 halves x to the negative 1, y to the 3rd. That's ugly. A lot of people won't see that. They don't like that. Y to the 3rd over 2. You can have that as an answer too. That's equally as ugly. This is probably your high school answer. Coefficients. That negative is a negative coefficient. Do not mistake it for a negative exponent. You cannot, do not write 10 times 12. No. You can't move this negative 12 up to make it positive and it goes in the numerator. That only works for exponents. Only works for exponents. This is a coefficient. So that's c to the 4th over c, and that's d to the 2nd over d. So this reduces to 5 over negative 6. This is c to the 4 minus 1, and this is d to the 2 minus 1. That is 5, c to the 3rd d over negative 6. That's going to be your best high school. Notice I didn't write d to the 1. 2 minus 1 is 1, but we don't write the 1 in our answer. Coefficients, like bases, like bases. So that gives me negative 1/2 s to the 4 minus 1, t to the 1 minus 4. Negative 1/2 s to the 3rd, t to the negative 3rd. Let's keep the things in the numerator. The negative 1, I wouldn't write negative 1s to the 3rd. 2 is in the denominator, and I'm going to move that t to the 3rd down into the denominator also. Got rid of the negative exponent. I am not going to write negative 1s to the 3rd. Do not write negative 1s to the 3rd. Write negative s to the 3rd. Not in red. Let's write it in black. 5 over 15. U to the 2nd over u to the 3rd. V to the 6th over v to the 8th. So that's going to be 1/3 u to the 2 minus 3. V to the 6 minus 8. So 1/3 u to the negative 1, v to the negative 2. That is one answer you can have. You can also have 1 over 3u v squared. That's the high school. Let's go back to that one. Can I have left? What did I do? Yeah, I could have, well, you could write this as -1/2 s to the third t to the -3 is one of the answers. You got a whole slew of yuckiness, lots of different things, but that's another one that for that last one. All right, now remember, like bases, we have like bases and we're multiplying them. So that's 6x squared plus 1 because we're multiplying, and in the denominator we are multiplying, and so we're going to add those. So that's 6x to the third over y to the fourth. We can't simplify that any further. That's a little bit of a trick question because we see division, but there's nothing we can divide. I like that. We again are multiplying, so we are going to add their bases, and 2 is in the denominator, n to the 1 plus 3. So that's m to the 7th, 2n to the 4th. All right, now, so constants. We have 2 over 1, 3 over 4 times. We have a over a squared, b cubed over b. So here we can cancel these. That becomes 1, that becomes 2. So we get 3 halves times a to the 1 minus 2 because we're dividing, b to the 3 minus 1 because we're dividing. That is 3 halves a, 1 minus 2 is -1, b to the second. So that's one answer you can have. Or you could also have 3b squared, stays in the numerator, 2's in the denominator, and a. Those are two good ones that you can do. Let's take the constants again. 8, 15. We have x and x squared. We have y over y cubed. That's good. I didn't think about writing it that way. Those are numerators. So what can we cancel? The 5 and the 15 becomes 3. The 2 and the 8 becomes 4. So we get 4/3 x to the 1 plus 2 because we're multiplying, y to the 1 minus 3 because we're dividing. That's a really good question. 4/3 x to the third y to the -2 is one answer. Or we're going to take the 4x to the third, stays in the numerator, 3's in the denominator, and y squared because we got rid of that negative exponent. Good ones. All right, so we have a power of a power. We have an exponent that we have to simplify first before multiplying. So we have to do that exponent. Exponents we're going to distribute. So the p to the third over q stays for the time being. Then we distribute it to all three of those. So that's 3 squared, q squared, p squared. Let's simplify it a little bit more. We have p to the third over q, and we have 9q squared over p squared. All right, so we have our constants. Then we have our p's. We have p to the third over p squared, and we have q squared over q. We're just matching things up. We have 9p to the 3 minus 2 because we're dividing, q to the 2 minus 1 because we're dividing. 9pq is our answer. Same thing, we're going to deal with that exponent first, and we're going to distribute it to, we are going to distribute it to all 4. 4? I only see 3 things. You should see that negative, you should see the t, you should see the 2, and then you should see the r squared. So 2r cubed over t cubed times -1 squared, t squared, 2 squared, whoa, r to the 2 times 2, power of a power. Lots of stuff. So 2r to the third over t to the third. This negative 1 squared is 1. T squared, 2 squared is 4. R to the fourth. Now let's deal with the coefficients. Let's deal with the r's. And let's deal with the t's. So that's going to reduce to 1/2. That is going to be r to the 3 minus 4. This is t to the 2 minus 3. So we get 1/2 r to the negative 1, t to the negative 1. That is one answer you can give. Or you can give 1 over 2rt. When you have multiple variables, you always want to put them in alphabetical order. So we have exponents that we have to deal with. Remember, this needs to be distributed to each of those. And then we have this exponent that we have to distribute out also to each of those. So let's do that before we do anything. So x to the 2 times 2, y to the 3 times 2 over x to the 3 times 2 and y to the 1 times 2. Don't know if you see that there's a 1 there. That gives me x to the 4th, y to the 6th over x to the 6th, y to the 2nd. Let's separate those. X to the 4 over x to the 6th, y to the 6th over y to the 2nd. We are dividing, so we're going to subtract them, and that takes place in the numerator. And that becomes x to the negative 2, y to the 4th. That is one answer you can give, or we can get rid of that negative exponent by moving the location. It's in the numerator, we can put it in the denominator. Let's distribute again. You get a to the 1 times 2, b to the 2 times 2, c to the 1 times 2, over a to the 3 times 3, b to the 1 times 3, c to the 2 times 3. That's a to the 2nd, b to the 4th, c to the 2nd, over a to the 9th, b to the 3rd, c to the 6th. Let's write them, pair them up. That's a to the 2nd over a to the 9th times b to the 4th over b to the 3rd, c to the 2nd over c to the 6th. And that gets written as a to the 2 minus 9, b to the 4 minus 3, c to the 2 minus 6, a to the negative 7, b, c to the negative 4. That is one answer. That's a horrible 4. Or we can write it as b over a to the 7th, whoa, c to the 4th. Both answers are correct. Yes, let's go. We are done. Woo. All right. That's 2 really good worksheets that we have completed. Good luck.